Okay, so let me share my screen again. All right. All right. It's recording. Done. Okay. So I would like to start this with an example. Okay. So what we learned in the previous section is that you see, right? We can, if it is a continuous function, we can say that limit x goes to c, f of x is equal to fc, right? If the function f of x is continuous, if f of x is continuous at x equals c. Okay, we can do that. Now, let's see whether we face any problem. So if you have function f of x equal to 1 over x squared, right? What kind of function is this? It's a, what do you call, a rational function. Okay, this is called rational function. Right? Now, is this function defined everywhere on the real line? For all the real numbers? Is this defined for all the real numbers? What numbers, what values is this isn't defined, if it is? Eight? X? I didn't hear you. 8, number 8? Just x. X is not a number. X is a variable, right? What I'm asking is x can take any value in the real numbers, right? Real numbers are going from negative infinity to positive infinity, right? There are infinite number of numbers in the real number space or real number set, I would say. So out of that numbers, at which numbers this function is not defined, if it is not defined anywhere? Huh? Corner. 0. Why isn't it defined 0? When the denominator becomes 0, the function is undefined, right? We say that it goes to infinity. That means it's become, but it's not really defined. Something is divided by 0 is not defined, so it's not defined, right? So this function is defined everywhere except x equal 0. So now that, keep in mind, this is continuous. Except at x equals 0. Right? This is continuous except at x equals 0. Okay. So now I am asked to find limit x goes to 3, 1 over x squared. Now, is that continuous at that point? When limit goes to 3, when x reaches 3, yes, it is continuous. So what can we do? We can do the substitution, right? So what is substitution? F of 3, right? F of 3 is 1 over 3 squared. 1 over 3 squared, right? 1 over 3 squared. So this is 1 over 9. Does that make sense? So that is doable. This is doable, right? Let's take another example. Consider this. Consider this. Limit x goes to 4, x squared minus 16 divided by x minus 4. Okay, what's happening there? Now, what we try to do? We think that these are, okay, so x squared minus 16, is it a continuous function? Yeah, it's a continuous function. X minus 4, it is continuous except at x equals 4. Well, I mean, 1 over x minus 4, right? Just x minus 4 is a continuous function, but at x equals 4, 1 over x minus 4 is not continuous, right? But what we're trying to do, we can direct substitute. But when we direct substitute, what would we result in? We would result in, if I direct substitute this, what would happen? This is 0, right? Why? 4 squared is 16, 16 minus 16 is 0, right? And this is 0 too. Now the problem, 0 divided by 0, something that's called indeterminate. Indeterminate. So what are the other instances that we get indeterminate problems? These are. We get indeterminate problems when we have situations like infinity divided by 0, infinity multiplied by 0, infinity minus infinity, right? And then the last one is 0 divided by 0. So these are the indeterminate cases. So whenever we are facing something like this, we are trying to solve this function first algebraically, and then we need to find the limit. Sometimes that limit exists, sometimes that limit does not exist. Here's what we do. Very simple, okay? We need to learn a little bit of algebra, right? So what we do is limit x goes to 4, x squared minus 16 divided by x minus 4. Now, if I use if we use our algebra knowledge, how can we write this x squared minus 16 differently?
X minus 4 and x plus 4.
Yes, right? Difference of squares, right? We can write, it's like a squared minus b squared equal to what? A plus b times a minus b. Remember that? Okay, so you can write x minus 4 times x plus 4 divided by x minus 4. As long as x is not equal to 4, this is not 0. What does it say? X approaches 4, right? X approaches 4. X not equal to 4, x approaches 4. So we can cancel these two out. So what we are left with, we have this. Can we find the limit now? You can use basic limit laws, summation law across x and 4, right? You get limit x goes to 4, x plus limit x goes to 4, 4, right? And this is what? 4 plus 4, which is 8. Does that make sense? Whenever we face indeterminate case, first thing that we do is to algebraically solve that expression or simplify that expression a little bit. and see whether we can find the limit. Okay. Let's take a look at this. Example 3. So we have limit x goes to 3, x squared minus 4x plus 3 divided by x squared plus x minus 12. Now when x goes to 3, what would happen? If I substitute now, just by looking at these two, these are two polynomials or rational functions. They should be continuous, right? Should be continuous. So yeah, I can substitute. So if I substitute 3, the first term, what would happen? If I do substitution, 3 squared plus, minus 4 times 3 plus 3 divided by 3 squared plus 3 minus 12, right? The first one is 9. 9 plus 3 is 12. This is negative 12, so it's 0, right? And here is 9. 9 plus 3 is 12. Negative 12 is 0. 0 divided by 0. 0 divided by 0. That makes sense? Okay. So, indeterminate case. I misspelled it again. Indeterminate. Right? So what we do? We try to algebraically simplify this. So how do we simplify this? Factorizing quadratic equations, right? Quadratic functions. 3 and negative 4. What do you get? X minus 3, x minus 1. Is that right? And then this x squared minus x squared plus x minus 12. So you have what? 3 times 4, right? 12. 3 times 4 is 12. So you can write x plus 4, x minus 3. Do you know how to factorize the quadratic functions? You learn it, right? So if you don't know how to do this, please come by and ask me. Okay? So what is the secret in learning algebra and calculus? What is the secret? Study. Study every day. That's the only thing. Okay? Do more problems. Just by looking at the problems, you won't learn. You have to do the problem by yourself and figure out where you can do. Ask questions from your teachers, from your friends. That's the only way. Okay? These are not difficult subjects. It's the time that you put in. That's it. Okay. All right. So we'll see. Now x minus 3 can be cancelled to x minus 3, these two, right? And then you can write limit x goes to 3, x minus 1 divided by x plus 4. And then now you can substitute, right? These are two continuous functions. It's not discontinuous 3, right? Denominator does not go to 0. So you can find 3 minus 1 divided by 3 plus 4 is 2/7. Does that make sense? Yeah, let's go to the next one. So this problem, this is the next one. Limit x goes to 1, x cube minus 1 divided by x minus 3, x minus 1 cube. Now, when you substitute, this is example 4, okay? When you substitute 1, right? It's going to be indeterminate case. Why it is indeterminate? Because both numerator and denominator goes to 0. Now, what if only denominator goes to 0? What? When x approaches some value, if the denominator goes to 0, what does that mean? The limit goes to where? What does it mean by the denominator approaches 0? Denominator becomes smaller and smaller and smaller. What does it mean? The limit goes to what? When the denominator goes 0, smaller and smaller, the limit goes to up. Where? To infinity. The limit does not exist, but limit goes to infinity. So that x equals that value becomes a vertical asymptote. Right? It's not an indeterminate case. In that case, we can determine that the limit does not exist. The limit goes to infinity. Why did it become indeterminate? Because 0 divided by 0. That is indeterminate, right? So let's keep that in mind. Okay. So now we have difference of cube on top, because 0 divided by 0, we know that it's indeterminate. Now what we do is trying to simplify this algebraically, right? You remember this? A cube minus B cube. How do you write that? A minus B, A squared plus AB, yes, AB plus B squared. Very good. Right? That's the difference of cubes, right? So, and then we can write limit x goes to 0, set for 1, I'm sorry, let's go to 1, x minus 1, and then I can write x squared plus what is a plus b? A times b here is x, right? X and then plus 1. And then you have x minus 1 cube, right? And then you can cancel to this one of that, and you have x squared, x minus 1 squared. So you have limit x goes to 1, x squared plus x plus 1 divided by x minus 1 squared. Now, can we simplify beyond that point? Can we simplify it more? Why is that? But this is cube. Square, not square, it's a cube. at the first. You don't see it? I'm sorry. No, it's 3. Now it's squared. So we cannot progress beyond that point. Now we have to take the limit. Now when we take the limit, what is happening? What is happening to the numerator? Numerator is equal to what? Numerator is equal to 3, but the denominator still goes to 0, which means this goes to infinity. So the limit does not exist. See the difference? It's not an indeterminate case. Why? Because numerator has a value, finite value. But altogether, function goes to infinity, so that it is not defined, or it does not exist. Does that make sense? What you see the difference between the two cases? Right. And let's take a look at this. Let's see. I think I want. Yeah, let's look at this one. Example 5. Limit tangent x divided by secant x when x goes to pi over 2. Okay, so think about these two functions. So what happens? Tangent x goes to pi over 2. We talked about it, right? 1 over 0. That means it goes to infinity, right? And secant x, what is secant x? 1 over cosine x, right? 1 over cosine x secant x. So cosine, when cosine x goes to pi over 2, what happens? Cosine x goes to 0, but 1 over cosine x goes to infinity. So both functions go to infinity. So it's an indeterminate case. So I just need to, indeterminate case, I need to add this one also. So I think I didn't add that previously. This includes infinity over infinity as well. Okay. All weird cases. 0 over 0, infinity over 0, what? Yeah. 0 over 0, infinity over infinity, infinity times 0, and infinity minus infinity. Actually, this should be changed to infinity over infinity. I just need to remove that one. Yeah. So that's one. These 4 cases. These 4 cases. Yeah, that's right. So now this case, it is infinity over infinity. Now let's see whether we can algebraically simplify this. Okay. So how do I simplify this? When I knew nothing about trigonometric solutions or identities, what I did was, okay, this is what I did as a student. I converted everything into sine and cosine. So let's do that. So limit x goes to pi over 2. This is sine x divided by cosine x. And the denominator is 1 over cosine x. Right? In the numerator, it is sine x times 1 over cosine x. Right? And the new denominator, 1 over cosine x. Right? So what we have here is, I'm going to write extra step in case if you don't see it. This is what we have right now. Does that make sense? So I can cancel these two. Can I do that? Yes. So then I have here is this. So what now? When x goes to pi over 2, what happened to sine of x? Is it a continuous function? Sine of x at pi over 2? Yes. And then we can do substitution, right? So now what? Sine pi over 2. What is sine pi over 2? Sine 90, sine pi over 2? 1. Okay, good, great. 1. So that's the limit. See that? Okay, let's do a couple of problems. Couple of more problems, okay? So we did what we did. We did example 5. This is example 6. So we have this. Do you have any questions? Sorry, I forgot to ask that. Good? Are all good? Okay. Sit Lali, good? So far, so good? Okay.
All good.
All right. Let's take this one. Limit. Go to right limit again. X goes to pi over 4 sine x minus cosine x divided by tangent x minus 1. So at pi over 4, all of these functions are continuous. Sine x continuous, cosine x continuous, tangent x continuous. Now, what is the debacle? What is the problem? When you substitute pi over 4, what would happen? What is sine pi over 4? Sine pi over 4 is 1 over square root of 2. Cosine pi over 2 is equal to sine pi over 2. Are those two equal? Yeah, let's see. Let's see. What is cosine pi over 2? You can find in your calculator. We don't remember. So not pi over 2, it's pi over 4, okay? Pi over 4. I just mistaken. Pi over 4. So pi over 4 is 45 degrees. Do you know that? Pi over 4 is 45 degrees, right? Pi over 2 is 90 degrees. Half of that is 45. So 45 degrees, at 45 degrees, if you draw a right angle triangle, right? If you draw a right angle triangle, it's 45. So if this has to be 45, then this must be 45. What is that? Why is that? Because this is 90, right? Which is equal to pi over 2. Now, if that has to be 45, that means pi over 4, this must be 45. You agree with me? Why? The internal angles of a triangle should be equal to what? What is the summation of internal angles of a triangle? 180. So this is 90. This is, if that's 45, then the other one should also be 45. Are you with me? Now, if this is length A, what is the length of this one then? A, because you have two same angles and the side facing to that, right, should be same. So this is an isosceles triangle. Isosceles right triangle, right? If this is A, what is this one? What is hypotenuse? Pythagorean theorem. What do you get? The square root of A squared plus A squared. 2A squared of the square root. So that means square root of 2 times A. Right? This is what? This is A squared plus A squared. Are you with me? That is 2 times A squared. 2 times A squared, right? What is that? Square root of 2A. Make sense? Right? So what is sine pi over 4? What is sine pi over 4? If this is A divided by square root of 2A. Cancel that. 1 over square root of 2. Does that make sense? What is cosine pi over 4? Adjacent leg, right? Adjacent side divided by hypotenuse, right? A divided by what? What is hypotenuse? Square root of 2 times A, right? Cancel that. 1 over square root of 2. That makes sense? So what is tangent pi over 4? A divided by A, which is equal to 1. Right? Good. Right? So now if you substitute what happened? Sine pi over 4 minus cosine pi over 4 is equal to? What is that equal to? 0. And the denominator, tangent pi over 4 is equal to what? 1. Minus 1? 0. So it's an indeterminate case. See that? Okay. So actually, this is a good one, right? This is a good one, and I can derive like that for pi over 3, pi over 6. What is that? 30 and 60 as well, which comes really handy in calculus, right? Sine 30 is half. Cosine 60 is half. Sine 60 is square root of 3 over 2. Cosine 30 is square root of 3 over 2. Okay. And you can get the tangent from that. If you draw a small triangle like that and try to do it, you figure it out. Okay. So that's easy way of doing it. Okay. So let's go back to this problem. So now we figured that it is an indeterminate case. So I need to algebraically solve this. Okay, simplify this. So I'm going to do it. Limit x goes to pi over 4 sine of x minus cosine of x divided by sine of x divided by cosine of x minus 1. Like I said, I don't know anything about this trigonometric identities. What I all did at that time was to convert this to sine and cosine. And now I would solve it. Limit x goes to pi over 4. I leave this one sine x minus cosine x. And I find the common denominator for the denominator. What is the common denominator for these two terms at the denominator? What is the common denominator for those two terms? Cosine x, right? I can write like this. I can write sine x, common denominator cosine x minus cosine x. Okay, does that make sense? So now this one and that one is the same. This is 1 over cosine x, right? So what you have here is you cancel this out, or you have limit x goes to pi over 4, 1 divided by 1 over cosine x. Okay. So 1 over cosine x is just 1 over cosine x is cosine x. This is just cosine x, right? 1 over cosine x. Does that make sense? It's cosine x. So cosine pi over 4 is what? 1 over square root of 2. Right? Does that make sense? This becomes what? Cosine pi over 4, which is 1 over the square root of 2. Good. Okay, let's do another one. Is there any questions on the previous cases? Okay. Yes, Jason. These examples? Or did you take a note? Well, what I can do is right now is I'm recording this. Yeah, I think I'm recording this. I can upload that. Works? Okay. And yeah, most of these examples coming from your textbook. They are coming from your textbook, actually all of them. But sometimes I write down the number, but sometimes I don't. So in case I have to write down the number, I'll tell you. So that from the example, okay? Okay, so now we have another case. Limit, try to take your notes down, okay? So that is a good practice for you in the class. Taking notes down is a good way of connecting with your brain. So listening is good, but taking note down is excellent while you're listening. So when x goes to 5, limit of this term. So if you put 5 in there, the first one becomes 50, and then 45 minus 5 is 0. And the bottom is obviously 0. So we want to do algebraic simplification. So let's simplify this one. So I had to factor this out. So I put 2x and x, right? And you have 5 here, right? So I put minus 5 here and then 1 here. Does that make sense? So I have 2x minus 5 is 10 minus 10x. This is plus 1x, 9x, right? You can do that. You can do another step like this as well. What I would do when I was training, right? This is what I did. I put 2x squared here. Now I have 9x here, negative 9x, right? If I multiply 2 and 5, I get 10. I get 10, right? So if I factor the 10 so that I get negative 9, how would I write? I should write, because I get negative 10, I write negative 10x plus x. So I make 9x at the middle, minus 5. See what I mean? I multiply 2 and 5, that's 10. And I can factor 10, maybe 5 by 2 with prime numbers and 1 by 10. And I pick 1 by 10. Why? I need to make 9x at the middle. So I put negative 10 plus x, that becomes that. And then you have this, you can divide it by x squared minus 25, right? And then you have limit x goes to 5. Then I can factor this out, 2x, 2x minus 5. And I took x out, right? I took x out for the first two terms, and then take 1 out from this to x minus. Oh no, I had to take 2x. Sorry, I had to take 2x out, and then you get x minus 5, and then 1 x minus 5 divided by x squared minus 25. And I can put that what we learned previously, that is x plus 5 times x minus 5, 2x, x minus 5 plus x minus 5, right? So you have limit x goes to 5. I can cancel x minus 5 because I can take a factor x plus 2x plus 1, x minus 5 divided by x plus 5, x minus 5, right? And I can cancel these two. So you get limit x goes to 5, 2x minus 2x plus 1 divided by x plus 1. X plus 5. 2x plus 1 divided by x plus 5. So now we don't have any problem. I can substitute. So 10, 2 times 5 plus 1 divided by 5 plus 5 is 10. This is 10 plus 1, 11. 11 divided by 10. Can you hang around for 1 minute? I have to do one other problem. Is that good? All good? I know it said 50, 51 actually. Give me 1 second. I'll finish up with this one. This is from your textbook, problem 929. And that limit x goes to 1, 1 minus x by 2 divided by 1 minus x squared. Now this case is different than previous cases. Why? How would it become indeterminate? This is when x goes to 1, this goes to what? The first part? Infinity, yes. Infinity. And the second part? It goes to what? Infinity 2, right? So it's infinity minus infinity case, right? So this case is infinity minus infinity case, right? So what do? We do limit x goes to 1. Now I'm going to find a common denominator for this, right? I can write x minus 1, 1 minus x squared as what? You with me? I can write like that. Does that make sense? Then I can write limit x goes to 1. My common denominator would be 1 minus x times 1 plus x, right? And I can write for this one, it's 1 plus x minus 2, right? On the numerator. And in the numerator is that, and I can simplify the numerator. What is numerator if I simplify it? X minus 1 divided by 1 minus x times 1 plus x. So I can take a negative 1 out of the numerator. It will become 1 minus x. Or if I cancel to this become negative 1. Does that make sense? Does that make sense? Because I can take negative 1 out, right? And then this is limit x goes to 1, negative 1 divided by 1 plus x. And now I can do substitution. It's negative 1 over 2. Okay, is there any questions? So we covered 2.5 today, and I'm going to upload the videos for tomorrow. And we are not going to meet in person tomorrow. Tomorrow online. And then we will meet again on Thursday. Sounds good? My advice is to work on problems every day. So once you get out of the class, not right now, but find some time, maybe an hour or an hour and a half, right? Because this class is 3 hours, a little bit longer, maybe hour and a half, right? For 1 hour class, I would recommend only 1 hour, but you need a little bit longer because you cover a lot of material in one class. Review what the things that we have done in the class. Do some problems, right? Today. And tomorrow morning, you find some, maybe 1 hour or 45 minutes or 1.5 hours, depending on how you get it. Work on the problems. Prepare for the next lesson for tomorrow. Remind the stuff that you did previously. And it's a continuous thing. Build on top of the other. So if you do that way, every day, it's not difficult to pass calculus. Okay. That's my advice. So I have given this advice to many of my advisees previously, and some of them followed it and passed the classes. They came to me and said that, oh, I did that and I passed the class. I was not teaching the class at that time. Okay. I was in engineering. I was teaching my engineering classes, and these students, whoever needs help, come and ask me, hey, Dr. Dharmaratne, I'm going to fail this class. What do I do?